Okay, we're going to start back up with number 38. It says graph the following quadratic equation. All right, so I've got to determine whether it opens up or down. Since a is negative, that means that it opens down. I need to find the vertex. So in order to get the x value, I'm going to do negative b over 2a. So 2 times negative 2 is negative 4. So that gives me 2. So my x value is 2. I can then take that and plug it in to find my y value. So this is going to be negative 2 times 2 squared, which is 4, plus 2 times 8, which is 16, minus 1. All of that said and done, I get 7. So I want you to think about a different way that you could do this to get 7. Could use synthetic division. So we got x is 2, right? And so then my coefficients here are negative 2, 8, and negative 1. So this is my negative 2, right? So 2 times a negative 2 is negative 4, which means this is 4. 2 times 4 is 8, which means this is 7. So my remainder is 7, which makes my y 7. So not maybe, I doubt any of you would probably go down that road to do it that way, because you can just plug it back in and get 7, but I just want you to think about how and why that works as well, because that might come in handy in some other situation. So we have now that our vertex is at 2, 7, so I'm going to label this B since that's where we get that from, and determine if it's a maximum or minimum value. Well, since that opens down and that's the vertex, when I go to 2, 7, right there, it's going to open down, so that has to be a maximum value. So I want to find the x and y intercepts. So to find my x-intercept, I'm going to try and factor this. Doesn't factor, so we are going to use quadratic formula. So for that, x equals negative b plus or minus the square root of b squared minus 4 times a times c, all over 2a. So that gives me that x equals negative 8 plus or minus the square root of 64 minus, it's going to be a negative 8. I'm sorry, that multiplies together to get a positive 8 times a negative 1 gives me a negative 8. So 64 minus 8 is 56 over negative 4. So then I want to simplify the square root of 56. So 56 is 4 times 14. And 14 just has a 2 and a 7 in it, so I can take the square root of 4. And that's going to give me negative 8 plus or minus 2 times the square root of 14 over negative 4. Then I can reduce all of that and get that my x-intercepts are at negative 4 plus or minus the square root of 14 all over a negative 2. And then make those both positive. So it's just 4 plus or minus the square root of 14 over 2. So instead of rewriting it, because I'm kind of out of room, I'm just going to, oh, dang it. I'm just going to erase those. If I had more room, I'd do it. All right, so there's my x-intercepts. Okay, then my y-intercept. Okay, so my y-intercept is when x equals 0, so 0, 0 leaves me with a negative 1. Y-intercept, there's my x-intercept. Then my domain, D, domain, oh, I guess I can finish drawing this. This is here, and then my y-intercept here is at -1. Get a couple other key points. If x is 1, then that's going to give me -2 plus 8 is 6, minus 1 is 5, so it's 1, 5, which means it should be here as well. And then it's going to look something like that, but a whole lot better. Good enough. Okay, so my domain is going to be all real numbers. And then my range goes from -infinity to 7. All right. Number 39. I'm going to find the equation of the following lines, write the equation in point-slope form, and in slope-intercept form. Well, when you got to write the slope-intercept form, unless you have the y-intercept, then doing it in point-slope form is easiest. So remember that is y minus y1 equals m times x minus x1. That is your point-slope form, and then, of course, slope-intercept form, y equals mx plus b. Okay, but we don't guess at what the y-intercept is. So if I have that it contains -4, 5 and has this slope, then slope-intercept form is pretty easy. This is going to be y minus 5 equals the slope, which is -3/2, times x minus a -4, which is x plus 4. So there is my point-slope form. Then to get it in slope-intercept form, I'm going to simplify that. So that's going to give me y minus 5 equals -3/2 x minus 6. And then I can add 5 over here, and I get y equals -3/2 x minus 1. And there it is in slope-intercept form. All right, so then the next one passes through these 2 points. So in order to do this, I need the slope. So my slope is delta y over delta x, and that is -6 minus 6 over 9 minus a -9, which is going to be -12 over 18. It's going to be a -2/3. So that is my slope. And then, so for point-slope form, I actually have 2 different options because I could use either point. So I'll just go ahead and do them both. So I could do, if I use the first point, it could be y minus 6 equals the slope, which is -2/3, times x minus a -9, so it's x plus 9. Or it could be y plus 6 equals -2/3 times x minus 9. So either one of those work. So then I'm going to simplify either one of them to get it in slope-intercept form. I'll do this one. So I get y minus 6 equals -2/3 x minus 6. And then I'm going to add 6 to both sides, and then I get y equals -2/3 x. So there it is in slope-intercept form. All right, so then I need a line that is parallel to that line and passes through that point. Oh. All right, it's not cooperating. There we go. So if it's parallel, that means it has the same slope. So the slope here, I'm going to make this is 4y equals -2x plus 7. So y equals -1/2 x plus 7/4. So my slope is -1/2. and it passes through this point right here. So that's going to be y minus 5 equals the slope, which is negative 1/2, times x minus a negative 3, which is x plus 3. So there it is in that. And then I'm going to simplify this. So y minus 5 equals negative 1/2 x minus 3/2. So then I'm going to add 5 to both sides, which means I'm going to add 10/2, and that's a negative 3/2. So that's going to give me y equals negative 1/2 x plus 7/2. There you go. So I'm supposed to graph this linear function. Well, I can easily put that in point-slope form. I'm sorry, in slope-intercept form. So if I just move these all over, I'm going to get y equals 2x plus 3, which means my y-intercept is 3, and my slope is 2, so I'm going to go up 2 over 1. I can also go down 2. Oh, I just went up 2 over 2. So I'm going to go, my rise is up 2 over 1, like I said. I could do down 2 over 1, and you don't have to plot 1,000 points, but I'm going to do a couple more so I can get my line straight. How many points does it take to determine a line? 2. Only takes 2 points, but doing more of them will make sure I can make it a little bit more line-like. There you go. All right, so there's my line. Refer to this piecewise function, and I'm going to find these things. So f of negative 4, right? So if x is negative, it's less than 0, I'm using this part right here. So this is going to be negative 4 squared plus 2. So I'm going to get 18. So if f equals 0, it's in this part right here. So I'm going to get 0 minus 2, absolute value. So absolute value of negative 2 is 2. If f is 1, it's greater than 0, so it goes in here. So I'm going to get absolute value of 1 minus 2. So that's the absolute value of negative 1, which is 1. Then I need to graph it. So x squared plus 2 if x is less than 0. So x squared would be a parabola, but I'm going to go up 2. So that's my vertical transformation there. So I'm going to go up 2, and then let's see, so it's going to look something like this. I can't get my pen right. Okay. So there's that part. This is really an open circle here, but I'm about to attach it to this one, so that's why I went ahead and made it closed. But since it says less than 0, it's not actually including this point, but this point is included in the next part. So then my absolute value function, since this is absolute value of x minus 2, that means that got moved to the right 2. And then I'm just going to that, and that right there, and this is an arrow because it keeps going and keeps going that way. That doesn't look too bad. All right. Next one. All right, for questions 44 through 51, we're going to refer to the following functions to find the indicated function values. All righty. So I need f plus g of 3. So basically, first I need to start by finding f plus g of x. So I'm going to take f of x, which is 2x squared minus 4x, and I'm going to add to it gx, which is 4x minus 1. So f plus g of x equals 2x squared minus 1. So then I can insert the negative 3. So that's going to give me 2 times negative 3 squared minus 1, so that's 9 times 2, which is 18, minus 1 gives me 17. So this is 17. So then f minus g of x, so I'm going to find f minus, just f minus g of x, so I have to find. So f, I'm not going to write that then. So that means I'm going to take f of x, which is 2x squared minus 4x, and then I'm going to subtract g of x, which is 4x minus 1. So I have to put that in parentheses. These are big time important. Do not be messing up on stuff like this, because that becomes 2x squared minus 4x plus 1. Plus 1. So this is 2x squared minus 8x plus 1. There we go. All right, h of negative 6. Well, when I plug negative 6 into here, that's going to give me 1 over 0, so that is undefined. All right, so g of k of 12. So let's find k of 12 first. So that is going to be the square root of 12. And that gives me 2 square root of 3. So then I need g of 2 square root of 3. And so it's going to give me 4 times 2 square root of 3 minus 1. So I get 8 square root of 3 minus 1. All right, 48. G divided by h of x. So g of x is 4x minus 1. H of x, so I'm going to divide it by h of x. H of x is a fraction, so when you divide by a fraction, you flip and multiply. So that means I'm going to multiply this times x plus 6 over 1, or just plain old x plus 6, which is going to give me 4x squared, and then minus x plus 24x, so that's plus 23x, and then minus 6. All right, h divided by j of x. So h of x is 1 over x plus 6 divided by j, which is a fraction, so I flip and multiply, times x minus 1 over x. So put these in parentheses. And then I can multiply straight across, and I can get x minus 1 over x times x plus 6, or really should multiply all the way out and get x minus 1 over x squared plus 6x. Some squared there. Okay, here I'm going to find g of f of x. So g of x is 4, and instead of x, I'm going to plug in f of x and get 2x squared minus 4x. And then, so that was like 4x minus 1. I'm going to simplify that. I'm going to get 8x squared minus 16x minus 1. That's all I can do. So then g of x. So g of x starts with 4, and instead of x, I plug g of x into itself, and I get 4x minus 1, and then a minus 1. This gives me 16x minus 4 minus 1, so that is 16x minus 5. All right, next one. Solve each inequality, write the solution in interval notation, and graph the solution in the number line. Let's see how many more problems there are. Okay, so to solve this, I'm going to distribute and get 2x minus 8 is greater than x plus 8. So that means when I move the x over here and the 8 over here, I'm going to get x is greater than 16. And so since x is greater than 16, let's write it in interval notation and graph the solution. So Here's my number line. It's greater than 16. Oops. That would be an open circle. Once it goes away. All right. Open circle here at 16. And my arrow goes this way. And then my interval notation would be 16 to infinity. Okay, so solve interval number line. All right, so here I've got, I'm going to subtract 4 from each side. So this is going to give me a negative 2 is greater than or equal to negative 3x, which is greater than or equal to a negative 9. Then I'm going to divide everything by 3. I'm sorry, by negative 3. So that's going to give me 2/3 is less than or equal to x, which is less than or equal to 3. You've got to flip your inequality signs around. So there is the solved. To get the number line, it's between 2/3 and 3, so and that's inclusive. So this is 2/3, this is 3, and it's all this in between here. And then interval notation, since I'm including them, it goes from 2/3 to 3. So solved number line interval notation. All right, 54. I am going to solve this quadratic, and I can factor this one. So this is x, this is x, this is minus, so one of them is plus, one of them is minus, and that would be a 4 and a 1, so the 4 has to be positive. This is 1, and then it is less than 0. Okay. Which means that two solutions here will be negative 4 and 1. So on this number line, and it's open, I've got negative 4 and 1. It's in between there, and then interval notation, negative 4 to 1. All right, absolute value of 2x minus 4 is greater than 6, and so that's going to mean that 2x minus 4 is less than negative 6, or 2x minus 4 is greater than 6. So I get 2x is less than negative 2, so x is less than negative 1, or 2x is greater than 10, which means x is greater than 5. All right, so my number line here is going to look like this. Here at negative 1 and 5, and going this way. So this is negative infinity to negative 1 and 5 to infinity. So kind of separate that, solve it, and all of that. All right, I'm going to stop here so these videos aren't super long, and then I'll pick up on the next one.